Hello and welcome back if you're following along this series where I make a 2D top-down horror shooter. And without further ado, let's continue. Last time we implemented the 2D shadow casting game mechanic to prevent the player from looking around corners. Today we want to add darkness and lighting to our game. Now before we begin, there is a small bug with our camera. And to demonstrate that bug, I am going to make this wall right here. So right now our screen resolution is a 16 by 9, and the bug lies in if the player changes the screen resolution, it throws off all of our calculations on our screen to draw all these shadows. So here I'll demonstrate it. If we change it to a 4 by 3 resolution, you can start to see how this wall is not lined up with its shadow anymore. Now if I end the game and I start it back up in 4 by 3 resolution, everything seems fine again. And if I change it back to a 16 by 9 resolution, everything falls out of place. So in order to fix this, we're going to open up Visual Studio. And here in the game camera start method, after we grab the camera, we want to set its aspect. And we do this by cam.aspect, and we're going to set it to 4 by 3. And we want to have these declared as floating point numbers, because if we do integer division, 4 divided by 3 would only equal 1. With floating point numbers, we'll have our 1.333333. Now that we manually set our camera aspect will always be 4 by 3 until we call cam reset aspect. And since our camera aspect is always going to be 4 by 3, the width of our camera will always be the same, preventing our draw shadows from appearing out of place. So let's save our work and give this a test. So here we started our game in a 16 by 9 aspect ratio resolution, and then we'll change it to a 4 by 3 resolution, and everything still appears to be good. And now let's change it to a 5 by 4 resolution, and we're still good. So that fixes that bug. Now we can begin our darkness and lighting. And we'll begin by clicking on our camera. We'll right click to add a child, and that's going to be a sprite square. And we'll call this sprite square renderer. And what we're going to do with this is we are going to make our sprite 640 by 480. And that is the width of our camera. And remember, we can find the width of our camera. All we do is we take this height times 2 and multiply it by the aspect ratio. Now this render is going to be our darkness, and I'll just make that 1 for now so it appears on top of everything else, but it's still in front of the camera. And this position right here is relative to the camera now, since it's a child of the camera. In order to make this sprite render our darkness and lighting, we're going to have to use a custom shader. We could use code to do this, but for simplicity, we're going to use shader graph. And in order to get shader graph, we have to go to our package manager. Here in the package manager, we're going to be searching for packages in the Unity registry. And scroll down until you see our shader graph, and we're going to install the shader graph. Once our shader graph is installed, we're gonna create a new shader graph, and it's going to be an unlit shader, and we'll call this darkness. And we'll just open this. And here we have a blank shader. And then we're going to create a new material. Call this darkness as well. And in this material, we're going to set the shader to shader graphs darkness. And here in our renderer, we're going to set the material to our darkness. And here Unity is telling us that our shader doesn't have a main text texture property. And the main text texture property is what the sprite renderer uses to draw the sprite with. So in our shader, we'll go ahead and add a texture and call it main text. If we click on our main text, its reference is underscore main text, which is exactly what Unity wants. So we'll save our asset, and you can see our warning's gone now. So now let's go back to our darkness shader, and we'll go to our graph settings. And here in our graph settings, we are going to set the surface type to transparent, and our blending mode will be alpha. And here you can see it added an extra alpha channel on top of our RGB channels. Next, let's drag our main texture in, and we're going to create a simple sprite shader. First, we needed to sample our texture. And make sure this space is in object space. And what we're going to do is we are going to send our alpha to the alpha channel, and our RGB, we're going to create a node called combine. And we're going to drag our R to R, our G to G, and our B to B. And we'll send that out to our color. Let's save our work and test this. Let's go to our scene. And here in our scene, let's make our scale 1:1, and let's drag our player sprite on here, and there you have it. Our renderer is drawing the player sprite perfectly with alpha. So let me just undo all that. Let's go back to our shader. Now the problem with shader graph is that we can't access any of this other information given by the sprite renderer. So since we can't access the color of the sprite renderer, we're going to have to create our own color. And we'll go over to our shader and create a color and just call it color. Now to replicate what the sprite renderer does with color, we're going to drag our color into our graph. And what happens here is we're going to have our color multiply by the texture color. So we'll use a multiply node. And then we're going to use a split node. And R, G, and B. And A will go to the alpha. Let's save our work. And let's go look at the scene and see what we can do here. If we go to our material, we can change the color here in our material now. And we can even set our alpha. And since this is darkness, we're going to make this black. And we control the darkness using our alpha channel. Since we can control the darkness using the alpha channel, we'll also use the alpha channel to make lighting in our scene. In order to change each individual pixel's alpha channel for lighting, we have to use what is called a mask. In this darkness, we want to give our player a flashlight, so we're going to make a flashlight mask. I'm going to open up Project Dog Waffle, freeware version 1.2. And you can use any image editor as long as it supports gradient filling with your paint can. So I'm going to take my paint can and I'm going to gradient fill, and I'm going to go from white to black horizontally and just fill that image in, and then I'm going to save it as a bitmap and just call it flashlight. I'm going to close this program and I'm going to edit it in MS Paint. Here in MS Paint, I'm going to take the line tool and I'm going to draw a line from that edge to the center, and our center is 75. So I'm going to go 5 pixels away from the center and make that 70. And I'm going to draw another line from this edge and 5 pixels away from the center. Next, I am going to fill in the rest of this with black. And here, this is how our completed flashlight mask should look like. And how we use this as a mask is our white equals 1 and our black equals 0. And somewhere in the middle here is 0.5. And we're going to use that data to manipulate the alpha channel in our darkness. So now let's save our work and go to Unity. And here in Unity, we will import our new flashlight. It'll still be a sprite, and it's going to be 1 pixel per unit. Its pivot will be the left. And we're not going to generate physics. Hit apply. Next, we'll drag the flashlight onto the player. And we're going to change the Y relative to the player down so that it looks like the player is holding the flashlight in the player's right hand. Now, as you can see, the flashlight is being drawn as a sprite, and it's not being used as a mask to manipulate the alpha channel of the darkness. So what we want to do is we want to create a new layer, and we're going to call this the light layer. And we'll make our flashlight the light layer. And in our main camera, here under calling mask, what we want to do is we don't want to draw the light layer. And now, as you can see, the light is no longer being drawn as a sprite. Next, we're going to create another camera. It'll be the child of the main camera. We'll call it darkness. And this camera is going to have all the same settings as the main camera, except its position will be unchanged relative to the camera position. And what this camera is going to do is it's going to pick up only things in the light layer. So here you can only see our flashlight mask. And it's going to render everything in the light layer to a target render texture. And that render texture is going to act as one big light mask. So in order to do that, we're going to set the background clear flag for this camera to black, and we're going to create a new render texture. We're going to call this render texture light mask. And in the settings, we'll make it a 640 width by a 480 height. Everything else looks good. We're going to go to our darkness camera, and we're going to drag our light mask into our target texture. To prevent confusion, I'm going to rename this camera and call it light mask. And I'm going to rename the renderer and call it darkness. Now that we can render our light mask texture, let's go to our darkness shader. And we're going to create a new texture 2D, call it light mask. And here in light mask, we want to make sure it's exposed. Now let's save our work. We'll go to our darkness material. And here in our light mask spot, we're going to drag our light mask render texture in. Next, we're going to go back to our darkness shader. We're going to drag our light mask in. We are going to sample it. We're going to change it to object space. And we're going to demonstrate how this light mask works by dragging it to the output And we're going to delete this alpha channel. Let's save our work. And if we go to our game scene tab and we move our player around, or rotator player, you can see that our light mask is continuously being updated by the light mask camera. Now we want to use this light mask data as the alpha channel in our darkness shader. So let's go back to our darkness shader. We'll make the main text the original color output. And for our alpha channel, we can use R, G, or B as our alpha because we're using grayscale, and that makes R, G, and B all equal. And for me, I'll just use the red channel. Let's save our work. Let's test it. And as you can see, we got the exact opposite of what we want. It's dark where our flashlight is, and it's light where the darkness should be. So let's go back to our darkness shader. So what's happening here is where there's white in our light mask, we're having completely opaque alpha. And where there is black in our mask, we're having completely transparent alpha. Because white equals 1 and black equals 0. So what we want to do is we want to take our red channel and we want to flip it. And we can flip it using the 1 minus node. And then we'll drag that into our output and save our work. Let's test it. So now we got what we want, but there's still one other problem. Now we can't control the darkness with our color. So in order to do that, we need to go back to our darkness shader. And what we need to do is we need to multiply our color into our light mask and bring that to our alpha. Save. Let's go to our game tab. And now you can see we can change the darkness of our world and still have a light mask. So we're nearly finished with our darkness and lighting. All that's left to do is we need to be able to change the darkness as we move throughout the level, because we may be in certain areas where we're outside and we want the lighting to be a little brighter if it's like a full moon. And in certain areas of the game, we may want it to get darker. Say we go into a room with all the curtains closed and it's pitch black. So we'll do this by creating a new script, and we'll call it darkness. We're going to open up our darkness in Visual Studio. We'll delete our start and update functions. Now in order to modify the darkness, if we go back to Unity and we look at our darkness object, we're going to grab our sprite renderer and we're going to modify its material's color. Let's go back to Visual Studio. So the first thing we're going to need is a sprite renderer. We'll call it darkness. And we're going to create a public function that returns nothing called setDarkness. And it'll be public because we want other game objects in the game to set the darkness if we need them to. And this setDarkness function is going to take a float called alpha. First, we want to check if our darkness is null. And if darkness is null, then we want to get our component, sprite renderer. And once we have our sprite renderer, we will create a new material property block called MPB. And that will equal new material property block. Next, we need to fill that material property block with the current materials in our sprite renderer. So we'll call darkness get property block and plug in MPB. And then what we're going to do is we're going to tell MPB to set color. And the ID for this property is going to be underscore color. Now if we go to Unity and we look at our darkness shader, you can see our color reference is underscore color. Back to Visual Studio. We want our color to be new color. We want it black, so it'll be 000, and then we'll plug in our alpha. And lastly, we will set the darkness with the new material properties by darkness.setPropertyBlock, and we'll plug in MPB. We'll save our work, and let's go back to Unity. And in our darkness, we want to drag our darkness script on. Now there's lots of ways we can use to reference this darkness object. We could give it a tag and search for it, but that can be slow and should only happen in the start or awake methods of an object. We could add a serialized field to an object and plug our darkness into it, but that can be tedious and you have to do that for every single level. Since there's only one darkness, we can use a static variable. So let's go back to Visual Studio, and in our darkness script, we're going to create a public static of the type darkness. We're going to call it settings. And then we're going to use our awake method, and in our awake, we're going to have settings equal this. Now let's save our work. To test this, let's go to our camera script, and in our start method, we're going to say darkness, settings, set darkness, and we're going to set the darkness to 0.25. Let's save our work and go to Unity. Now in scripting, when we set color, we're using a %. And here in Unity, they measure color from 0 to 255. So right now the color is, I would say, around a 90%. So if this works, we should get a lighter darkness. And it looks like it worked. If we go to our darkness and look at our color, it set it to a 64. Right now Unity is telling us that we have 2 audio listeners in the scene, and I completely overlooked this. If we go to our light mask camera, when you create a camera, it comes with an audio listener automatically, and we only need 1 in the scene, and that'll be on our main camera, so we'll remove this audio listener from our light mask camera, so it'll stop this warning. And now finally, before we end this part, we're going to have our player be able to toggle the flashlight on and off. So we'll go over to Visual Studio, and in our player script, we are going to create a new key. We'll call this key flashlight. And we're going to need a new serialized field to plug our flashlight object into. It's going to be a sprite renderer. We'll call that flashlight. And now in our update function, we're going to say key flashlight is equal to input get key down. We'll use the key code F. And now we'll ask if key flashlight was pressed in this frame. What we're going to do is we're going to have flashlight.enabled will equal not flashlight.enabled. So if the flashlight is enabled, we'll make it false. And if the flashlight is false, we'll make it true. Let's save our work and go back to Unity. We'll click on our player object, And here our flashlight, we need our sprite renderer for our flashlight. So we'll drag our flashlight object onto this and it'll grab the sprite renderer from our flashlight. And now let's test this out. And there you can see I can turn my flashlight on and off. Now to demonstrate the lighting and darkness mechanic in our game, we're going to go back to our game camera and I'm going to take away this darkness setting, save it, go back to Unity, and we're going to leave it at the setting that it's currently at. And we're going to drag another player sprite into the scene. I go to the scene, drag another player sprite in, and let's run it. So you can see our light and darkness really help make the game more spooky. And you could use a completely pitch black darkness to get the most surprise, or you could use some sort of darkness like this, a semi-dark room, to kind of just mess with the player's eyes, make them think like they saw something. And that's all for this part in making the 2D top-down horror shooter. If you'd like to follow or dub along, don't forget to subscribe. See you next time.